Now it's your turn to algebraically find and then interpret the vertical and horizontal intercepts for an application of a quadratic function. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. We're given here that a cannonball is launched off a cliff. Its height h in meters after t seconds can be modeled by h equals negative 4.9 t squared plus 12t plus 100. To start, let's make sure we're keeping track of our horizontal and vertical axes. So t is on the horizontal axis, and h will be on the vertical axis. So when we find the vertical intercept, we're going to be finding the h-intercept, and that will occur where t is 0. So to find this, we'll replace t equals 0 in that equation. So we'll have h equal to negative 4.9 times 0 squared plus 12 times 0 plus 100. And that will simply equal 100. So we know that when t is 0, h is 100, and so if we interpret this in the context of the problem, t equals 0 is the instant that that cannonball is launched, so we could say the initial height is 100 meters. Next, we're going to find the horizontal intercepts, and then we'll interpret them. So again, on our horizontal axis we have t, so these are the t-intercepts, and they'll occur where h is 0. So to solve where h is 0, we'll set negative 4.9 t squared plus 12t plus 100 equal to 0. We'll solve this quadratic equation using the quadratic formula. So we'll have t, and it will be equal to, and then we'll write a fraction, and in that numerator we're going to have the opposite of b, which will be negative 12, plus or minus, and then we'll have a radical, and inside that radical we'll have b squared, which is 12 squared, minus 4ac, so that'll be minus 4 times negative 4.9 times 100. And that's all over 2a, so it's all over 2 times negative 4.9. Simplifying that, we'll see that t is then equal to, and in the numerator, we're going to have negative 12 plus or minus, and then we'll simplify what's inside that square root. We'll do that in a couple steps. 12 squared will give us 144, and then we're subtracting 4 times negative 4.9 times 100, so we can turn that into 144 plus 1,960. And that's all divided by 2 times negative 4.9, which is negative 9.8. Let's simplify this one step further, and we'll have t equal to, and in the numerator we'll have negative 12 plus or minus the square root of 2,104, all divided by negative 9.8. That radical the square root of 2,104 could be simplified, but here we're going to go through and just round these for approximate decimal values. The first one we'll get is t approximately negative 3.456, or for the second solution, we'd have t approximately 5.905. Now, before we interpret this in the context, a negative t value doesn't really make sense. The cannonball wasn't going anywhere before it was launched. So in context, that first one doesn't make sense. So this one doesn't apply in context. So we'll only use that second value for t, approximately 5.905, when we interpret this. What we started with was h equals 0, and we found that there were two approximate values for t, one of which applies in context. So when h is 0, t is approximately 5.905. Looking at the context, that means the height is 0 after about 5.905 seconds. So we'll summarize that. The height is 0, and I need my units, which are meters, so the height is 0 meters after about 5.905 seconds.